Hello, everybody. Thank you so much for coming today. Appreciate you guys. My name is Kevin Jones. I am a DevRel engineer working for Edge and Node, working in the Web3 space, working on the Graph protocol. Really excited to talk a little bit about blockchain with you guys. To start this out, I'm really curious in the crowd, and we're going to need some participation. So if you're out there, who here knows what a blockchain is? Raise your hands. Okay. Who here knows how a blockchain works for the most part? Who here has a wallet, crypto wallet? You wallet people? Cool. Who here has actually sent a transaction on the blockchain? Cool, we got some cutting edge people. I love you guys. Who here knows Solidity? A little bit. Oh, we got maybe coming into Web3 Solidity dev. Okay. Who here knows GraphQL? That's the easy one, right? Everyone knows GraphQL. Well, welcome. I'm going to give you guys a little bit of a dump on knowledge. Sorry, for some reason that's not going through. We're going to talk first about a blockchain. I think the general idea for blockchains has been around for a while. Everyone kind of understands a little bit of what they are and how they work. But if we think about it from a really high-level distributed systems way, really all it is a distributed data storage that's secured by cryptography. So it's a ledger, and that ledger is storing state, right? And all those nodes essentially unite together as one single computer, one single state machine, right? And the idea is that through consensus, all of the nodes on the network provide security for the transactions that are being published to the blockchain, and provide a reliable source of data that you want to get from the blockchain, right? If all the nodes are in consensus that a transaction is valid for so long, it becomes valid. And a transaction is exactly that. It's a command written to the blockchain that is specifically for the pure fact of updating state, right, or changing state, right, to that network. Or maybe it's proposing a new smart contract, which we'll get to in a second as well. What is a smart contract? So a smart contract, you can think of it as a decentralized piece of code that is deployed on the blockchain that has data and has logic on how to manage that data, right? So it also is in charge of managing state. So you can declare variables, you can have functions, you can do, different things within the contract. You can do access control, right? Smart contract is literally that. It's just a way to manage particularly transactions that are coming through. So any person proposing transactions to a smart contract can alter the state of something on the blockchain, right? So if we think about this in the literal sense, we can go to an example of CryptoPunks. Who here has heard of CryptoPunks, right? Super awesome little JPEGs that blew up on the internet and are pretty overpriced, maybe. I don't know. Depends on how you look at it. But they are these artworks, different pieces of art that are relative to the data storage that's on the blockchain. So an NFT contract is essentially a smart contract that's deployed. It's called an ERC 721. Basically, it is a data store. So here we have the CryptoPunks as an example. We have all of the IDs that are coming through for all the different, basically instances of that CryptoPunk. We have who their current owner is, right? And then we have the metadata URI, which is basically just the referenceable data on the CryptoPunk. So you can find out, well, what does it look like? Where does the JPEG live? What kind of traits does it have? Different information, the detailed metadata that's off-chain, usually. But there are some problems with blockchain data, and I'm going to kind of try to surface those and talk a little bit about how the graph solves those problems. So first, we have this problem of provenance, okay? Historical data. Like, how do we know on a particular CryptoPunk who owned it at a certain period of time, right? It's really hard to get from the blockchain. You have to really know exactly all of the blocks that have happened and been validated on the network. You have to know exactly when Alice sent a CryptoPunk to Bob. And you have to be able to query that using a special JSON RPC instruction. And it's very difficult to really keep track of that in some other database. You also have this, so an example would be something like this, right? Where we have time machine, right? Where we can actually go back in time at a specific change of state, right? For the smart contract and see what's going on. And then we also have this initial architecture. So the initial idea of a DApp, or a decentralized application, is that you have a front end deployed in some kind of decentralized way, and you have a blockchain that holds the logic to the smart contract and holds the logic for the business logic for your application in a blockchain cryptographic way, right? But the problem is that blockchains are actually incentivized for reads. I'm sorry, for writes. When you secure a transaction and you want to update state on your smart contract or on your application on the blockchain, you sign it. You sign the transaction, you change the state, you pay some gas, which is basically the security incentive for the network to validate that transaction for you and to update and run some processing power to change that state. But where does the incentive lie for reading? There is none. You can read for free from the blockchain. You can read state. But the actual architecture of the JSON RPC is really not designed for reading data. It's designed for checking the current state at an exact time block, the current block or something like that. And it really is not useful because you can't grab large amounts of data from the blockchain either over the RPC. We also have this problem of like, in general, we see with any protocol, as it gains momentum, new things come onto the network and you start to see this clog of data. So MakerDAO, Uniswap, Aave, these are all different dApp applications that live today that are very highly used and highly successful. And it's a sea of mess to look at one particular block on the blockchain and try to sift through that data. It's very difficult to do. If you want to get information about just Uniswap or just Aave transactions, it would literally, you'd have to loop through all of the transactions in a block just to get the data you need. So it is a little bit of a mess. And what we're end up with something like this in code that we see. This is actually a live query that we saw in production where someone was trying to get the list of NFTs for a particular wallet that was connected to the dApp. And so in this case, we're looping through and doing a loop to determine how many NFTs is in that wallet. And each time you query the blockchain with a JSON RPC call, that could take anywhere from 100 milliseconds or more. So if you have a user that has like 10 or 20 wallets or NFTs in their wallet, you could easily have a load time of like 10 seconds or 20 seconds, which is not a great user experience. And we're trying to make Web3 an interesting and good user experience. So this is where the graph comes in. Okay, so the graph is a decentralized indexing protocol for blockchain data. So what does that mean exactly? The main goal of the graph is to provide an API layer for a decentralized future of applications. So in general, we know that there's large amounts of data sets on blockchains. And there's also other indexing protocols like IPFS and Arweave, and there's other networks. There's different blockchains, right? So we know that there's a huge opportunity to help organize the data. Just like Google indexes data and keeps it organized for their platform, we want to do the same, but we want to make it open and available for anyone to query in an open way, sticking to the ethos of Web3. Currently, the graph serves about 1 to 2 billion queries per day, which for Web3 standards, well, for any protocol, I would say is a pretty good platform in terms of like amount of usage. Some of our most popular protocols are here on the bottom, Uniswap being probably one of the #1 users of the platform. And really, like I said before, is we want to create the data layer for Web3, okay? An open place where anyone coming into the scene that is building dApps, building smart contracts, writing smart contracts can develop what are called subgraphs, and I'm going to get into that. And in the end, the graph is exactly that, is a decentralized indexing network protocol. And when I say decentralized, I mean that it is a community-based network of decentralized individuals that all provide value by storing and basically exposing that data to the consumer. So there's about 465 indexers. This number changes fairly often, but over 400 indexers that are all over the globe. There's over 11,000 delegators, which means these are people that are actually delegating some stake of GRT to the network to power it. And there's over 2,500 curators these are people that have either written subgraphs or believe in a specific subgraph that is written believe in the code and believe in the data set and have provided value to the network to allow that data to be served. And there's over 700 subgraphs. So we'll get into what a subgraph is, but those are the backbone to the graph network. So what the architecture of a particular DApp looks like with the graph is something like this. You still have your front end written in Next.js or React or HTML or CSS, whatever combination that you prefer. And you still have your smart contract deployed on the protocol and on the blockchain. But you have this additional layer that essentially sits in between there, and it's a middleware layer for the API layer, the indexing layer, the graph network. Okay. And so if you have a front end, you have the graph sitting in front of your application. You're still making transactions and proposing your write transactions to the blockchain by signing transactions with your wallet or whatever it is that your users need to do. But you're essentially feeding this data in from the blockchain over JSON RPC, and the graph is grabbing specifically what you care about as a developer and indexing that data in an organized way that you've programmatically created with your subgraph configuration. So the end-all goal is for anyone coming into Web3 to build truly decentralized apps. There's obviously still use cases for centralization. We think we all know that. But for something like a smart contract, which is emitting public events on the blockchain anyways, it makes sense to make the data layer for that truly decentralized and open and available. And this also helps with collaboration between dApps, right? If new dApps come onto the scene and they want to utilize Uniswap data, or they want to use MakerDAO or whatever, there's a predefined market for that and already available. The data's there. So what is a subgraph? Let's look at it from a high level. So you can think of subgraph as exactly a data storage or a data object, where in this case, we're looking at Ethereum. We're pulling information that comes in through the smart contract by listening to events in the smart contract. So if anyone here has ever looked at smart contracts, you can essentially define variables, you can define functions, and when you want to log data, important data that's happening, or I should say activity inside of the smart contract, you emit an event. And so what the subgraph does is, as you're defined, you define the events that you care about, and that data is fed into a subgraph configuration and stored. And we're going to get into see what that looks like as well. So when we have something like this, where we have a large number of protocols, right, and they're all kind of trying to fight for block space and propose transactions, lots of users, we can kind of turn that into a more organized fashion with subgraphs. So you can imagine each one of these protocols has its own unique subgraph that can be queried and can be accessible for the user. And so what we're left is with something beautiful like this. Everyone knows this. If you're a front-end developer and you're at the GraphQL conference, you know this is a much better look. That same example where we had to kind of loop through and get all of the NFTs for a particular user can be simplified into one GraphQL query using something like this, where we're actually able to query for the ID of the particular NFT, what the token ID is. So the ID could be a unique hash. The token ID can be the actual token, like 0 through whatever. The metadata URL, who were the previous owners, which is very interesting, right? This is where we get into like customizing the subgraph. There's a lot of power to building a subgraph because you can build based on the kind of data object that you want. So in this case, this subgraph keeps track of all of those previous data. So again, this is just another look at kind of what that would look like. We have the user interface, we have the indexing protocol sitting in the middle, which is the graph, and then we have the blockchain sitting behind that. So this is kind of what the high-level architecture looks like. So you still have your DApp that's written in your front-end framework, JavaScript, HTML, CSS. Users that are using the app are still proposing transactions to the smart contract by just doing the normal smart contract mechanism. But then we have these events that are being, basically pushed out from the smart contract, and you have Graph Node listening for those events, right? And then you're running what's called a mapping. Okay, a mapping is an assembly script WASM module that essentially is listening for these events as they come through, and then storing that data in a Postgres database. And then the Graph Node exposes that data in a GraphQL API for you. Easy query GraphQL API. And so all your queries from your dApp can be then exposed through that query layer. So this is live footage of a subgraph in action. It's pretty amazing, right? I found out today that this is handled by different ball weights, and that's what makes us do this. But for the longest time, I had no idea how this worked. But yeah, if anyone can explain this to me in more detail, let me know afterwards. So if you want to query data on the decentralized network, what does that look like? So currently, there is, if you go to thegraph.com, and we can actually kind of look at it in real time here. When you go to thegraph.com, it's going to take you on like this splash point, and there's a Graph Explorer, which is going to allow you to kind of dig in and see existing data sets. And you can also even explore the data using the built-in kind of GraphQL query. So if we look right here, this one's fully indexed. We can hit play and see the detailed GraphQL query. Right, so it's very powerful. So if you're looking for building a dApp and utilizing an existing subgraph, you can come here and kind of look at that. If you're going to build a new particular subgraph, you can use the studio. You can connect your wallet and do that. But these are organized, already pre-existing industry standard subgraphs, and you can organize them by what their signal, their curation signal. So you can kind of think of the signal as in the amount of stake of GRT that's powering those subgraphs. So the higher stake, probably the more important subgraph and important data set that you're going to see. You can also create an API key. So there is a development environment. So if you're a developer just kind of getting started, you don't need an API key. You can query the development endpoint. But if you want to use this in production, you can create an API key and connect your wallet, create an API key, and then you can get access to that data. We also have one of our core devs. So the graph is powered by 6 core devs, different companies that actually all work together to support the graph protocol. And one of those is Masari. And Masari focuses on data and like optimized reporting of that data. And so we can kind of consider them the Bloomberg of Web3. And they have a particular mission to build industry standard subgraphs. And so we've had them kind of build out these very similar data sets. So you can kind of assume that if you go onto here, you can get a particular subgraph that's built by them that is somewhat written with the same kind of methodology across all the subgraphs. So a query might look something like this. You can query the gateway with your API key. You specify which subgraph you want. This is all provided inside of the studio and the Explorer. But you can essentially pass across whatever values you need inside of the URL. So it is very interesting in that sense. And you can get the data that you care about by passing a GraphQL query. Also, one of the other core devs who's here as well, which if anyone is around, I would highly recommend checking out their booth. And I think some of you guys are very familiar with them, is the Guild. And they particularly support the graph client layer for the graph. And this is very interesting because it is a very important aspect of the ecosystem for our users. And you can think of it as this layer that can sit on top of the graph. There's different use cases for how you might do this. One use case would be that you would sit in front of your graph instance for only like a read-only data. So you can do things like live queries and create a connection that is set up between the graph layer and the actual front end of your application and kind of embedded in there. You can also have this scenario where maybe you have multiple subgraphs that you care about, right? If you're doing a DeFi protocol, you might care about Aave, and you might care about Uniswap, and you might care about MakerDAO. You might care about different subgraphs. So Graph Client allows you to consume either similar subgraphs that are maybe on different chains. Like maybe you have your application living on multiple types of networks, like Ethereum and some other blockchain. Or maybe you just care about specific Ethereum subgraphs, and you can combine that data request into like one endpoint essentially, or one request. Or you might use Graph Client even without the graph. So the Graph Client has the ability to essentially send transactions as well, to do like mutation inside of the UI, And this kind of would allow you to do like a clear separation. Like maybe there's an instance where you don't want to use a subgraph and you just want to just query and read from the blockchain. Or you could do something like this where you're still utilizing the blockchain for reading the data and creating your subgraph configurations and reading those into the graph client. But you also might want to do some writing directly through the graph client to do the mutations, and then also do things like block tracking and managing time a little bit better as well. Or maybe you're building more of a Web 2.5 app, is what I call it, where you still want to maybe have a subgraph, you have a smart contract, or maybe you're building something around an existing smart contract. But you also want to provide some kind of like Web 2 infrastructure, and you want to bring in other sources of data that are GraphQL based. You could use Graph Client to do that, where you're pulling in different things, or maybe it's different sources like REST or XML, or a combination of that in gRPC. And this also allows you to do edge casting, which will give you faster responses in your front end. So I did a really good workshop. If anyone here is in San Francisco or in the area, we have a beautiful place called the House of Web3 in San Francisco. I'd highly recommend you check it out if you're interested in blockchain and Web3. We do a lot of events there. And I did this workshop, and it's recorded. It's available here in my GitHub repo. It takes about an hour and a half to do on your own, maybe a little bit longer. But it's a really good introduction to the graph because you actually build a subgraph, you deploy it, and it's all done locally. So you don't need to mess with API keys. You don't need to mess with the studio. You don't even have to use a crypto wallet if you want. You can actually go through this. There's a built-in wallet in the solution that's in here. So I highly recommend checking that out. I'm also going to be doing a full stack version of that over 2 days in a boot camp. So this is going to be taking place, I believe, in November. So it's a little ways away, so you guys have some time to kind of maybe do some investigating. But the boot camp is geared for actually Web 2 developers that want to come into the Web 3 space and learn a little bit more about what a subgraph is. We will do that in a more hands-on fashion if you guys are interested as well. I want to take a second to show off the subgraph configuration. So if we look here, I have an example project here, and it's a monorepo. So it's created with a Yarn package. And more specifically, I just want to focus and show you really quickly a very basic smart contract. And inside here, we can see that we have what's called a greeting change event. Okay? This greeting change event is just keeping track of a particular variable that changes based on a transaction that's passed. So it's a very simple smart contract. It's a state contract, and there is a function down here that allows you to update that greeting and emit an event. So with Solidity, you have this concept of emits. You can kind of think of them as logs. And so you pass across variables to the particular events here, and those variables are then kind of emitted on in your dApp and on the blockchain. And then the beauty of the graph is we actually come in here and allow you to create a subgraph based on your event data. So if you use the Subgraph Studio and go through the steps, it will actually build it out for you. You don't need to know how it works, but I want to kind of cover it really, really briefly. Let's look at the next package here, the subgraph. And by the way, this is the exact same workshop that I shared in the previous slides. So if you guys toy around with this, you'll be familiar with it. Inside of here, we have, there's three main components to a subgraph. The first is the subgraph YAML configuration. You can kind of, it's considered the manifest. And it's the high-level overview of how your how your subgraph needs to read information from the blockchain. So in this case, we have the things we care about are the address of the actual contract. So an address, you can think of it as like a location of where to basically interact with on the blockchain. Then we have a network. So in this case, this was a local workshop that we do. But if you were on, like, let's say, Ethereum mainnet, it would be something like mainnet. And then we have this concept of entities, which is the schema, the entities within the schema. And then we have these concept of handlers. And so the handlers are exactly that. They're how should this subgraph handle when an event is emitted. So in this case, we have an event handler that is called greeting change. So we care about the greeting, what the greeting was. We care about who the sender was of that greeting. And then we care about, obviously, how to handle that using this handler, okay? So you can think of this as, like I said, the manifest. It's the overall vision of how you need to define your subgraph. And then if we dive into the actual source and look at the schema first, so remember we care about the greeting and we care about the sender. And so we have these very easily defined schemas. Anyone who knows GraphQL is very familiar with this format, which defines what kind of variable types that we want to store within Postgres, right? And we even support interesting things like the derived from field here, where we can actually like make relationship data between our subgraph configuration or our entities. So we have two entities, greeting and sender. Some of this stuff is going to be generated at runtime when the subgraph processes, but some of these are passed along. So like things like the sender, the greeting, the Boolean. So how are those handled? Well, that is exactly what the mappings do, the handlers. So the handler is, again, assembly script. And it is runtime WASM. So basically what happens is when you deploy your subgraph to the network, this handler kind of just constantly listens for whatever business logic that you have inside of the handler. It is an assembly script, so it is a subset of TypeScript. So if you're kind of familiar with TypeScript, then you can kind of see it looks very similar. And inside, this is obviously where it probably gets a little more complicated, but for the most part, we just have this handler that takes in the event data called greeting change. And it does things like try to load the sender. If the sender isn't existing, then we might create the sender. We might set some information like when it was created using the timestamp from the Ethereum block. We might keep track of the counter of like how many times has this person actually created a message or sent this greeting change. So all of your logic is handled in here. And then finally, we have this save, which basically saves the data to Postgres and then exposes it in the GraphQL API that you see. So with those three things, you can build a subgraph. And if you're getting started and you go through the process of like connecting your wallet and coming in here, let's just connect it real quick so I can show you. Sign a transaction. It asks you if you want to put in an email. But if I say create subgraph and call it test, choose my blockchain, Ethereum, create subgraph, it provides all the steps for you to generate your subgraph. And the cool thing is if you are looking at an existing, oh yeah, it's hard to see, sorry guys, thank you. So if we look at this example, I just created a subgraph, and all the steps to go through here and create a subgraph, you can install the CLI, the Graph CLI, which is open source, initiate the studio, authenticate against the studio, go into the directory, and then this will actually generate the code and build it, and then you can deploy it. So it's a very easy developer experience. I think the hardest part is probably writing a smart contract. But like I said before, my workshop will guide you through that, and there's an example smart contract that you can use. So yeah, with that, let me just put this up here. Thank you guys for coming, and I'd love to answer some questions for you. Thank you. Sure.
Thank you. It's awesome. You mentioned the PostgreSQL database. I'm not sure if I'm capturing the concept, but is this something with off-chain and applies the graph.com?
Great question. So the question was about particularly the data, the Postgres data, where it's stored. So currently, there's two solutions with the graph. One is our hosted service, which currently is free, but that's something that we're moving away from. And then we have the decentralized network. The decentralized network is exactly that. It's a community of indexers that are all running the same stack, which is the graph node, Postgres, and IPFS. So when you deploy your subgraph, you're actually deploying it out to the network and saying, hey, somebody pick up my subgraph. I'm willing to pay some money to curate that. So it's almost like you deploy it, right? But you don't have to run the infrastructure. That's the beauty of it. They handle all the infrastructure, and it's deployed on the network. And then at that point, if you were a DApp creating a thing, you can just query directly to the network to get your data. So it is a decentralized. You obviously would have probably, if you curated it with the proper signal, you would have lots of indexers pick up your data. So then it would be highly available and distributed across the network. Good question.
Follow-on question is, if I build a subgraph that's going to be event-driven, but I want to tap into something that's been around for a long time, how do I backfill things that happened before I started?
That's a great question. So the question was about if you're starting to tap into existing data that's on the blockchain, how does that work? So when you do deploy your subgraph, you actually have to specify a start block. If you don't, it assumes the start block is 1. So it would actually have to go through the entire blockchain and index that data. So you typically would know, like, based off of Etherscan when a contract was deployed, like, you know, if you cared about Friendtech, if anyone knows that, that is probably not that old. So you could put the block from just, you know, few months ago. CryptoPunks is a little older, so you need to find that block. So that way you don't have to go back and parse the whole blockchain, or the indexers don't have to go out and give the whole the blockchain and make it a little more efficient. Good questions. Thank you so much. So I think I have enough for, I think I'm at time. Thank you guys so much. And if you have questions, I'll be here afterwards. Thank you guys.